Have you ever stopped to think about what happens when you make a call or stream a video? You're tapping into one of the most complex systems ever built. Today, we're diving deep into India's incredible telecom market to see who's building the invisible networks that connect more than 1 billion of us. Let's get into it.
And when I say 1 billion, I mean it. To give you an idea of the scale we're talking about, India's telecom market supports over 1 billion wireless connections. That's just a mind-boggling number of calls, texts, and videos happening every single second, all flying through the air.
So how in the world does this massive system actually work without collapsing? And who are the companies behind the scenes building and running all this tech that we rely on every single day? It's time to pull back the curtain.
Okay, at the very heart of this entire digital world are the telecom operators. These are the architects, the engineers. They're the ones who literally make all of our digital connections possible.
So what does telecom operator actually mean? Well, you can think of it in 3 key parts. First, they provide the services we use, like our mobile plans. Second, and this is huge, they physically build and manage all the infrastructure, the towers and cables. And third, they do it all using licensed radio spectrum, which is basically the invisible airwaves that carry the signals to your phone. It's a massive job.
Now, in India, you've got a few major players on the field. You have Reliance Jio, which completely changed the game with its focus on high-speed 4G and 5G data over an all-IP network. Then there's Bharti Airtel, another giant that's strong in both regular consumer services and enterprise solutions. You also have Vodafone Idea, which is really focused on optimizing its network for its huge base of mobile users. And finally, there's the government-owned BSNL, which plays a really crucial role in getting connectivity out to rural areas.
All right, so we know who the operators are. Now let's get into the really cool part. What they actually build. This is the invisible architecture, the actual nuts and bolts of the network that makes your phone light up. So the journey of your data has 3 main stops. It all starts at a base station. Yep, that's the cell tower your phone is talking to right now. From there, your signal goes to the core network. This is the brain of the whole operation, figuring out where your call or data needs to go. And what connects all these towers and brains? That's the fiber backhaul, which is basically a massive system of super-fast digital highways.
But let's pause on that first step, the wireless hop from your phone to the tower. How does that even work? It's not just empty space. Data travels through a very specific managed resource called spectrum. Think of it like invisible lanes on a highway that the government licenses out to operators.
And here's something you might not realize. Not all spectrum is created equal. You've got the sub-6 gigahertz bands. These are the real workhorses. They can travel long distances, so they're perfect for covering wide areas with 4G and 5G. Then you have the millimeter wave bands. These are wicked fast, like super high speed, but they don't travel very far. That makes them perfect for dense cities where you need a ton of capacity. Operators need a smart mix of both to make a network that actually works everywhere.
Okay, so we've got the operators, and we have their infrastructure. Now let's talk about what all of this actually delivers to us, and how we've gone from just making phone calls to the wild potential of 5G.
This whole system is what enables everything we do. It started with simple voice calls, then gave us the 4G mobile internet we can't live without. It powers our home broadband, and even specialized services for big businesses. But the next massive leap, the thing that's going to change everything again, that's the 5G revolution.
So what's the big deal with 5G? It really boils down to 3 things. High speed, that one's obvious. Faster downloads, better streaming. Improved capacity means the network doesn't get clogged up in a crowded stadium. But honestly, the real game changer is low latency. That's the near zero delay between when you send a command and when it happens. This is what's going to unlock things we've only dreamed of, like real-time gaming, remote surgery, even self-driving cars.
Now, this huge jump in performance isn't magic. It's some seriously incredible engineering. We're talking about advanced technologies like MIMO, which uses a bunch of antennas to send and receive way more data at once, and beamforming, which is a wild technology that actually focuses a wireless signal directly at your device instead of just blasting it everywhere. That's the secret sauce behind 5G. The future of all this is super exciting, no doubt about it. But getting there is not going to be easy. For our final section, let's take a quick look at the major hurdles these operators are facing as they build out the next generation of networks.
Building the future costs a lot of money. That spectrum we talked about, it is incredibly expensive for companies to license. Then there's the sheer logistical challenge of deploying towers and fiber optic cables to every corner of the country, especially rural areas. And all this is happening while our own demand for more data, faster data, is just skyrocketing, putting constant pressure on these networks to keep up.
This quote really nails it. It says that operators are the backbone. They're the ones who take all these separate pieces, the radio systems, the physical infrastructure, the complex software, and weave them all together into one single system that just works. They really are the backbone of our entire connected world.
So we've seen who builds our networks, what they're built from, and the challenges they face. But as our digital lives get more and more demanding, it leaves us with one big question. How will this incredible digital backbone continue to evolve to handle the future we're all building on top of it? Thanks for tuning in to this explainer.